So this is kind of an example of the canonical class, the most basic example. The even basicer one is, I love talking like that, even basicer was the circle where we have just one piece of data. But here's a class that's got two pieces of data in it, right? It's got two data elements called member variables, and then it's got 7 methods or 5 methods: set width, set length, get width, get length, and get area. So they're not going to show us the code for that. How nice. Oh, wait, that's the last slide. That's a bit hasty. All righty. So this is what's known as a UML diagram. And a UML diagram has these minus and plus signs in front of the variables and the methods, the functions. And the minus sign means that they're private, and then the plus sign means that they're public. And we've already talked about private and protected, private and public. There's a third category called protected. Private means that that data can only be accessed, or those methods can only be called from within the class itself. And you can't call it from the main code, the client. Public means you can. Protected means that it's private just to that class, but also any child classes. So what's a child class? All righty. So for example, you could have a class called animal. And then you could say that you're going to make 3 child classes of it. And a reptile has all the traits of an animal plus some extra ones to make it special, to make it a reptile. And then a snake has all the traits of a reptile plus something else. And a bird has all the traits of an animal. This sets up a relationship. A bird is an animal, and a parrot is the bird. So this is the parent class, and this is the child class. Some people would call this the superclass and the subclass. That's the Java textbook terminology. Superclass being the one that you are inherited from. So you can have child classes, as many child classes as you care to declare from the parent class. Well, the syntax for that is something like this. Here's the parent class. Oh, let's use that animal class. And what does every animal have? Every animal has a name. We better do the usual where we put our boilerplate in. So every animal has a name. And just to make it easy to use, I'm going to make everything public. All right. And then there's a class called bird, which inherits from the animal class. And what do birds have that are different than animals? They have feathers. So string feather colors, right? And then you could have a specific kind of bird, a parrot. Class parrot is a bird. And so you have an is-a relationship where a parrot is a bird and a bird is an animal. And then you have a has-a relationship where a bird has a feather color and an animal has a name. And so our bird has a favorite phrase. It's a parrot, so it can talk. That's its special ability. Just call it phrase. All right. So when you say superclass and subclass, super doesn't mean that it's super duper and has more capabilities or everything. It just means it's above it in the hierarchy chart. it actually has less powers, right? This is the superclass for the bird class, but all it has is one thing, whereas a bird class has two things because it has this and the stuff that it inherits from its parent class. And the parrot has three things, right? It's got both a phrase, a feather color, and a name. And we could prove that just by coming down here and making a couple of these guys, right? Animal PA is equal to new animal. And we're going to set its one variable, PA dash greater than name. See, there's only one thing listed. What does that do? Show more results? Huh, all right, anyways. All right, this animal's name is Fred. Okay, that's silly. Let's just say that it's I don't know, Alvin the Anteater, right? We don't have a mammal class yet, but all it has is a name. It can't do anything else, right? So now let's make a bird. Bird star PB for bird is equal to new bird. And so PB hyphen greater than, he's got two things available to him, although it's only showing one. Okay, once I clicked the plus, it showed the inherited stuff. And it's showing that name is private. It's got a little teeny tiny lock there. Not that you can see it, but maybe you can see that there's a little lock there next to it. And so that's because I did not mark the attributes, the inheritance as being a public. And so by default, it seems to be saying that everything that it inherits from the animal class is private. Now that wasn't my intention. I botched that up a little bit. So let's see how I'm going to fix that. I think I just put public here. And so I better do the same thing here. All right, so now when I type PB hyphen greater than, he's got feather colors too, right? So he's got blue feather colors, blue feathers. Now we're going to make a parrot. So parrot star PC for cockatiel, I know they're not the same thing, is equal to new parrot, like that. And PC, now he's got three attributes, right? We could fill in all three things. And this parrot likes to say, want a cracker. But we could also give this bird a name, right? We didn't only have to create his attributes, his feathers. We could have filled in his two available attributes. He's the bluebird. And the parrot's name is going to be Chatty Cathy. Excuse me. And the parrot's feathers color is white. So if you watch the other lecture where we had Pac-Man and we had ghosts, when I redid the lecture, I did not get into what Pac-Man had as well as what the ghost had. But a Pac-Man and a ghost share a lot of attributes, right? You know, the ghost had an X position and a Y position and a speed and a color and a name. And then he would have, the Pac-Man would have an X position and a Y position and a speed position. And all Pac-Man are yellow, but I guess you could make a multiplayer Pac-Man game. I've seen one of those. So let's do that. And the name. So they're identical, right? Well, no, the Pac-Man could also keep track of the number of points he has, right? And maybe he could keep track of what level he's on. That kind of thing. So what does a ghost have that's special to himself? He's got the amount of time that he'll be vulnerable after Pac-Man eats the power pellet, right? So I'm just going to call that blue time because they turn blue as soon as you eat the power pellet, and then they blink a couple times and then they're back to normal. And so blue time is his special attribute. So you can see that a lot of this stuff is shared between the two. So we could have done is we could make a class called agent. I mean, I could guess I could do it right in the code. Class agent. Let's make everything public again, just for ease of creation. And he's going to have a name. And he's going to have an X and a Y position. I'm not going to do this whole thing, right? That's enough. That's what an agent has. And then a ghost inherits from that. So the agent data is made public. So unless this is marked as private or protected, then the client code in main is going to be able to access the name and the X and the Y, and that's fine. So how about the ghost? What's his unique attribute? The blue time, right? Okay, so we're going to do that. Int blue time, how long he stays blue. And Pac-Man's got his own attribute. He is also an agent. He's got an X position and a Y position, and he's got a direction, north, south, east, or west. You know, so does the ghost. I guess I'll do that. But he doesn't have blue time, and he does have a score. So class Pac-Man is also an agent. So we're going to make all the public members of the agent class of his parent class accessible to main. I forgot to make this public, so I need to add public colon there. And here I need to make his score, right? Public colon, int score, int what level he's on, right? And int dots left on the maze, or maybe that stuff could be inside a different class or something like that. Let's just do that. Okay, so Pac-Man has got all the abilities of agent. Ghost has all the ability of agent, but they also have some shared stuff, right? I mean, some stuff that's unique to themselves. The Ghost has the amount of blue time left, and the Pac-Man has a score that's unique to himself. So that's another example of hierarchy, of inheritance. So when you see classes defined, is there any way I can get that to stop showing that? You probably can't see it, but there's the toolbar up at the top, the zoom toolbar, that I really would wish would go away. Is that going to do it? Is that going to do the trick? All right, maybe. Okay, so if we go to our Solution Explorer, View Solution Explorer, we go to Source Files. We see our lecture. Now, what you're kind of supposed to do, it's not mandatory in this language, unlike Java and C#, but you're supposed to put each class into its own file. And what's worse is you're supposed to put the classes in a split way where part of it is defined in a header file and part of it is defined in the CPP file. And it makes the class really hard to follow when you do this. Well, I mean, I guess if you're an experienced C++ programmer, it becomes second nature. The tendency is to want to do this. I'm just going to add a new item and define the entire class in a header file. And since this is going to be my circle class, I'm just going to call it circle.h. And so here's the tendency: to declare your class and to put all your code, including the method bodies, inside the header file. Circle has a variable called radius, and the circle has a public method called getArea. Don't know why I make radius an int. I want it to be a double, right? And since this is a private member, we need some way of getting and setting it. So void set radius which accepts radius as a parameter, and it is const compatible. No, it's not, because it changes data, right? If something's modifying it, it can't be const. All right, and then we say this hyphen greater radius is equal to radius, right? Now we have a setter for it. Now we're going to do a getter. It can't be void because it needs to actually get the radius and return it. It's going to have a return statement, unlike the setter, which doesn't return a value. So it needs to be declared as double. But you don't pass in any data when you're asking for the radius, right? You pass in data when you're setting it because it has to know what value it's setting it to. This one doesn't. And so this one just returns this hyphen radius. And then one more method, get area. It's going to return pi r squared. So it returns a value, so we need to give it a return data type, not just void. Get area. We're going to calculate the area. Equals 3.14159 times the radius squared. Guess I should include CMath so I can do that. Excuse me, pound sign include. No. Yeah, what's wrong with that? Oh, it fixed itself. All righty. So POW radius, comma 2. And then return the area. So a fairly important concept is that the class should just contain its core data and nothing that can be calculated on the fly. What do I mean by that? A lot of people in some classes I have taught would do, okay, you want this thing to have an area? Well, that's an attribute of a circle. I'm going to go put area up here. But it should be a calculated value, right? The area should always be calculated based on the radius. Why? Because what if you called get area and it calculated as some kind of area, but then you change the radius of it? Then the area is invalid. It's stale data. That variable has nothing left. That variable is no longer valid. So if we had declared a variable up here called area and we had calculated it, but then changed the radius, that is bad data. So we don't want to do that. Anytime you can calculate the value of it, that just needs to be something that's calculated as a local variable and returned rather than stored as a member variable, which is why we declared area here rather than up here. All right, this is almost good enough, but we're going to make a constructor. And the reason we're going to make a constructor is because I want to be able to do this. I want to be able to do circle PC is equal to new circle with a radius of 10. But I don't have to do that. We have a set radius method, so we don't have to add a constructor. Just for simplicity's sake, let's not. So if I want to use that in main, I'm going to have to go back in main and add a pound sign include for circle.h. Now, what does pragma once mean? You stick that at the top of all your header files so that if the same header file gets accidentally included more than once, then it doesn't break the program, which it's possible to do otherwise. And I'll tell you why you might get it included more than once. And I don't mean you just type in pound sign include circle 2 times in a row. It's more subtle than that. Okay, so it's a local file. And since it's a local file in the same directory as everything else, I put quotes around it. And now I could use the circle class if I want. So I could go down here and do circle PC1 or pcirc1, and it needs to be a pointer to it, so I can use the new is equal to new circle, and then I can set its radius and I can get its area. pcirc1 hyphen greater than set radius to 10, and then double area is equal to pcirc1 hyphen greater than get area. And I could print it out if I wanted to. All right. So That's what a lot of people like to do when they're defining a class, is stick it in a header file, right? And realistically, all of my animals should go in their own file. So I'm going to do that. I'm going to grab the animal and the bird and the parrot class, and I'm going to create a header file called animals. So I'm going to cut those, add and include, although I don't have the file yet, right? But I will in just a minute. Animals.h. All right, now I'm going to go back to my Solution Explorer and add a new header file. So right click, add new item. It's going to be a header file so that I can import it. Wait, I did that wrong. Right click, add a new item header file, and this is called animals.h. And I'm just going to paste this, but it's not going to work, so I'm going to have to add the # includes it needs, specifically string, right? So # include string. And I think I've mentioned before that not everybody agrees that using namespace std is a great thing. So if I'm making classes, especially classes that I want other people to use and not just me, I probably would avoid doing that and just refer to these functions by their namespaces, and that would fix that. Now it'll compile again. All right, it should compile. Let's find out. All right, and it didn't actually do anything, right? I never printed anything. So if I was going to make this a better example, but it fluffs it up and it makes it longer, I would make getters and setters for all the variables if I wanted to do that, right? I could do get name and set name and get feather and set feather. So your typical rules for classes. And it's kind of overkill sometimes. You just have to decide how protected you want to make your data. So your class rules, 1, name begins with a capital. That's like the least important rule, but everybody does it, so I'm listing it first. And then your data should be private, and your functions, your methods, public. And in 3, you add getters, which are not technically known as accessors, not accessories, an accessory to the crime, and setters, which are known as mutators. And then add constructors if it makes it useful to use. With a constructor, I would be able to do this. I could come down here and say, please make a circle and give me a radius of 10, right? And I did that on my other example, so I'm not going to do it again. And then the other rule is add a destructor if your class allocates new memory. So what if you want to assign default values as it's created? Well, let's go ahead and give our bird class, maybe just the parrot class. Maybe just the parrot class, the ability to set its values by default as it is created. Then that can be customized, right? But every bird is every parrot's going to have the name of parrot and feather colors of white. Now those can be customized, but that's what we're going to default them to. So we're going to make a constructor after all. Now a constructor is a method that has the same name as the class and no return type. So a constructor is a method that has the same name as the class does with no return type and is called by the new method. I guess we ought to add constructors for all 3 of these things, right? He's only got one variable to set. So let's give him a constructor. Animal, and he takes standard string name so that we can set this hyphen name equals to the name argument that's passed in. Now the bird. Let's give him a constructor, but it's just going to be a default constructor. So default constructor won't have any parameters in it. Bird, but we want to set the value of the name variable to bird when it is created. Let me make sure I do this correctly. So excuse my pause. So we're going to use a member initializer. And when this bird object is created, we want it to set the name of it. And I'm sorry, this document that I'm trying to access is taking forever to load. Well, fine. Try to do it from here. Okay. So C++ member initialization from the constructor. Constructors and member initializer lists. This is actually the one I'm trying to access on my iPad. Waiting for CPP reference. Yeah, that's about what I was doing over there. Get another one. All righty. So here's kind of what we want, is that when this thing is created, it sets these values. But there's an alternate syntax. That's not the only way to do it. And I'm looking for that alternate syntax. I said I'm looking for that syntax. Here we go. It looks horrible, but we can do it. What I'm going to do is I'm going to add the thing for the bird to where it says name curly brace bird, so that every bird we create automatically has its name set to bird. And so you do it like this: name curly brace quote bird end quote, like that. Now it needs a body as well, but its body doesn't actually have to do anything. Name is not a non-static data member or base class of bird. Okay, so I declared it wrong. That didn't seem to work. I may punt on this if I can't get it to work. Can I at least set the feather color? All birds have white feathers until decided otherwise. No default constructor exists for class animal. That's true. So we have a default constructor for bird, but it needs the ability to create an animal, and there's no default constructor for animal. So we're going to add a default constructor for animal. Default constructor just doesn't take any parameters, and in fact, it doesn't need to even do anything, although I could just set its name equal to animal if I wanted to, right? I bet we do it the fancy way. Supposedly, this is more efficient. So that's the name of the animal in the default constructor. Now what? Okay, great. It went away. All righty. Now let's put a print message in here saying animal created, just so that we know it worked, right? So std : cout animal created endl. And let's do the same thing if it's created with this non-default constructor. std : cout less than name created, right? \n. And now let's add a constructor here that says bird created. I think I'm going to mess this up a little bit more and make it say cout less than quote bird constructor like that. I'm just going to tag that on here so I can see which constructor is working, right? So bird constructor. If we pass in a name, great, it takes it. If we don't, that's fine. This is called overloading when you have the same function name, but with two different parameter lists. So down here, we're going to do cout animal constructor. And it doesn't have anything fancy that we're passing in. So I'm going to just not print anything else out. Okay, so if we go back over here to main, when we create our bird, we should see some messages pop up now, right? We're creating a bird and we are creating a parrot. We're also creating a circle, but it doesn't have any print messages in it. Error list. Unexpected tokens following preprocessor directive. Oh. In Java, after your import statements, you got to have those. And guess what class I taught right before y'all? ENDL is not identified. Why? Because I did not do using namespace. That's getting tedious. I probably should have done using namespace. I'm going to do that. It's going to be bad. Namespace std. Okay. All righty. And so the bird constructor was called when we created. See if I can get both those windows on the screen at the same time. Scroll down to main, scroll down to main. Where's main? I went too far up. So when we create this bird, it just called the bird animal constructor with its default name, right? But when we created a bird, it was supposed to say that it was a special thing, bird constructor animal created, and I don't see that it did. We've got it. Oh, that's because we didn't make it call the constructor. And I don't want to spend too much time on constructors, so I'm gonna kind of abort on this. I just want to see it call the animal class's constructor with data that we specify within bird. So how do we do that? This constructor, bird, needs to call the animal constructor. Wait, why is that called animal? No, that is animal. So where's our bird constructor? Here we go. We want a bird constructor, and it's going to call the animal constructor. And I'm going to Google the syntax for that so I don't take a wrong guess. Calling parent constructor C++. All right, so here's a class called base. And here's a class that's derived from the base class. And so when we call it the derived, y'all can't see that. The constructor for this needs to call the constructor for the base class, and it doesn't seem to be doing that. So with derived classes, things are slightly more complicated. I love it when they give you a bad example and explain why it doesn't work. I mean, I do that, but on a web page, it's nice to have the good example up at the top. Eventually, it'll show up. Here we go. We're calling the base class. So bird needs to call animal with the right animal to pass in, with the right value to pass in. So I'm going to come over here, and the bird class, it's going to set its feathers to white, but it's also going to call the animal constructor with the name birdie. So now when that main statement in main does bird equals new bird, it's going to call the animal constructor, and then it's going to call, it's going to call the bird constructor, and it's going to set the bird's colors to white, and then it's going to invoke the animal constructor. Now, probably I maybe ought to do those in vice versa order, but let's come up and look. And the animal constructor that accepts a name is going to print out bird constructor, and then it's going to say birdie created, because that's the argument that we're passing in to fill that. All right, so when we created our bird, the first bird didn't have any special attributes, right? We didn't pass in anything, so we used the default constructor here. Then when we called the parrot, we also used the default constructor. And we used the default constructor here too, but we could have set the animal name as we created it, right? Animal star PA2 is equal to new animal. And what is this guy? This is a road, this is a dinosaur, whatever. And so by the time we get to here, let's just stick system pause here. So to stop at the moment, it's going to have created two animals. One way is going to be with the default name that we then just go and assign a new name. And the other is when we set that animal's name with the constructor. All right, so the first constructor was the default constructor. And so it just picked up the default name of animal until we erased that name and reassigned it to Alvin the Anteater. But then the second time, why does this say bird constructor dinosaur created? Let me guess, I have the wrong message inside the animal constructor. I do. Why am I saying it's a bird? Animal, animal. All right, we're going to get off these constructor businesses in just a bit. I know lots of y'all's eyes are rolling up in your head saying, please stop. Okay, so let's run it again. As a matter of fact, let's add a couple more messages to it so that if we call this one, this is the default constructor. And so I'm going to put the word default constructor here. And here, this is the custom constructor because it accepts data. So I'm going to call it the custom animal constructor. Another name for a custom constructor is parameterized because it accepts parameters. This one doesn't accept any parameters. And since it's not accepting a parameter to set the name, it's setting the name to a default value. All right, so the default animal constructor, the name of that critter, since it didn't have a name, is animal. Then we turned around and we set it to Alvin. The custom animal constructor was called, but since we passed in something with parentheses, its animal name is dinosaur. And if we hit enter, the same thing will happen. The bird constructor called the animal constructor to set its name to birdie. And we go in and we could give the bird a non-default constructor as well that accepted the name, a custom name for it, right? So if we wanted our bird to have a custom name, it may be custom feathers. Well, it's got to call the default constructor with that name. And it's got to set the value, seems to be marking an error there. No, it went away, of the feather color with the variable feathers. And so we need our open braces and our closed braces. I'm just breaking that into 2 lines. Doesn't even need to do anything, but I'm going to make this say default bird constructor. And this is going to be custom bird constructor. I'm not going to bother printing the rest of that information. And we're going to see that happen 2 times, because when we create this bird here, it's just using a default constructor. But let's make another one. Bird star PB2 is equal to new bird. And this bird's name is Tweety. And Tweety's is yellow. Now let's stick in system pause down there instead. So the first bird we created was a default bird, and so I picked up the name Birdie. That's how the animal constructor was called. The second one, that constructor, the bird constructor was called. It was customized, and so it called the animal constructor. And notice the order in which it printed these messages out. Custom bird constructor, custom animal constructor. Why is that? Because when we create our bird, we're in the bird class, we go to our custom constructor, it does everything that's here first before it comes down and it starts doing this stuff. So it actually invoked the parents class constructor and set the value of the feather color appropriately before printing that message. All right, no more constructors. If you allocate RAM with the new command, you're supposed to delete the RAM before your program is done, or I should say when you're done using it. Now we've created several different objects, but we should delete animal PA, we should delete PA2, we should delete, how many others did we do? PC, didn't we have 2 birds? Delete PB. It'd be neat if we could do delete PB, comma, and PC at the same time, but I don't think that that's valid syntax. Maybe it is. Could I list them all at the same time? That'd be pretty neat. And then I had pcirc1, right? So delete pcirc1. That's just to release the RAM that they allocate. Now, in real life, none of these things have an allocation. The constructor doesn't have a new command in it. So it wouldn't be much of a memory leak, but still it's a good idea. So let's build it and run it. All right, at least it didn't crash. What do you know? You can delete more than one object. You can delete them all, right? I could just do delete PA, comma, PA2, comma, PB, comma, PC, and so on, and do them all at the same time. So if we needed to, we would go to the animals class or the circle class or whatever. And if it had a constructor, this one doesn't have a constructor. I don't think I ever created a constructor for the circle class, but we could do it for animals. A constructor has the same name as, excuse me, a destructor has the same name as a constructor, but with the tilde, the shift back apostrophe. And let's just print a message saying animal destructed. std : cout animal destroyed. And we'll see that message at the end of the program. I believe we have a system pause, so it's going to hang out there. But then when I finally hit enter, it called the animal destroyer. Now, we only saw it print that once. So apparently the bird constructor needs to have its own destructor, right? I thought that that might be called for all of them because every bird is an animal, but it doesn't have one. So I would need to go and add a destructor to my bird class as well if I wanted that to happen. I'm going to just copy this and change the name of it to bird. And so if the constructor allocated an array or any more objects with the new keyword, then this guy would need to delete them. Otherwise, you get memory leaks. And I talked about that last lecture, so I hope you watched it. Okay, so after we've done all of our animal creation, the animal was destroyed. Did I never delete any of my birds? Because I don't see any bird destroyed messages. Maybe you do have to delete them separately. Delete PB. Okay, guys, I'm sorry. I saw chat messages now and I haven't seen it. Okay, that's no problem. All right. So it ran our constructors and now it ran our destructors. I still only getting one bird destroyed. Is that the actual case? Yeah, because I deleted PB. So let's delete PA2 and let's delete PB2 and see if we get those destructor messages as well. And then we created something called a parrot right here. We called it PC. I wonder if that's going to print out any messages. Or if we have to write its own destructor. And that's my hunch. Okay. So when we deleted the bird, it's an animal, and so it destroyed the animal. Then we deleted the other bird. See, we have 3 birds. We could print out their names if we wanted to inside the destructor. Right? So this hyphen name less than bird destroyed, I'm putting that in the bird constructor. And so we're going to see the message that those birds were destroyed. Right? Bluebird was destroyed, which called the animal destructor. Maybe. No, I guess it goes in vice versa. Bluebird destroyed, which called the animal destructor. Tweety was destroyed, which called his animal destructor, or hers. And Chatty Cathy Bird was destroyed, which called that destructor. And the only purpose of the destructor is to delete any memory that these guys may have created. So, for example, if a bird has a circle, this is stupid, right? But if the bird class, if the animal class has a circle in it, right? Circle star PC, and the constructor allocated it, right? PC is equal to new circle. We have 2 different kinds of constructor for the animal. So I'm going to put that in both of them. Now both birds have a circle for whatever purposes. And then the destructor needs to delete that circle. We allocated it. Otherwise, like if you have a loop that creates 1,000 animals, and then we never call the destructor, then those thousands of that 1,000 circle objects are still in RAM, and you can run out of memory. Your program can fail. It's called a memory leak. Okay. So for animal to work nowadays, since it's got a circle in it, we'd better include the circle class. Circle is a local file, and it's called circle.h, so I need to put quotes around it and call it .h. Now, remember when I said you accidentally, or not even accidentally, you wind up including the same file more than once? Well, that's happening now, because in our main code, we are including circle.h, and then we are including animals.h, which includes circle.h. What this pragma once does is it guarantees that that file is only included once, even if there are multiple # includes for it, which is a good thing because you might have something declared in here that you could not declare twice. Like, this would be really bad programming, but what if we put a global variable declaration in the animal class? Well, then each time we try to import the animal class, let's put that in circle, because circle is the one that's being imported twice. We would wind up with two identically named global variables if it was included twice. But it's not, because of pragma once. No matter how many includes we have for it, it's only going to be created once. And so it ran. I'm going to delete that just because it's so silly. There we go. All right, about enough of that. Last thing I need to show you is the textbook way of declaring a class. And it may not even be this textbook's way of declaring a class. Let's go look. Nah, I don't want you to see my Pac-Man books. Those are secret. Those are my powers. All right, so when you declare your class, you declare your data, and you declare your prototypes for your methods. That's all that's supposed to be in the header class, are prototypes of methods. We put the whole method in there. So if we're going to do it the textbook way, and let's go ahead and do this. And if it's possible for you to type along, I'd like for y'all to go ahead and try to do this with me. We're just about to wrap this up. I'm going to create a new project and call it Lecture Y2. And if you can't type along, that's okay. I understand. Okay, so I know that I want the circle class that I'm about to create. So I'm just going to add a # include for circle.h up here. And I want it to work like this. I want to be able to create a new circle. It's underlining it because I don't really have a circle class yet, unless I went and copied it from the other one. Circle P1 is equal to new circle. Let's pass the radius in like this. And then let's get the area out. Double area is equal to P1 hyphen greater than get area. And then we could see out circle area equals end quote less than area less than ENDL. Using namespace std. Alrighty, so that's what my main looks like, and I'm probably not going to even make any changes to it. But I need a circle class. So what I'm going to do is I'm going to go to the Solution Explorer. I'm going to right-click on Source Files and do Add New Item. I wonder what the class wizard is. And I'm going to make it a C++ class. And what's the class name? Circle. So you saw what I did. I just right-clicked, Add New Item, chose Class, and named the class. I did not give it a file extension. And the reason why is because it creates the extensions for us, circle.h and circle.cpp. And notice that it gives us the option of specifying the parent class, the base class. Those terms are synonymous, the base class. All right, click OK. And if I look at my Solution Explorer now, it's created a circle.h for me, which has got nothing in it except for that pragma statement, I bet. And then it's got a circle.cpp, which has got nothing in it probably except # includes circle. Okay, is anybody who's typing this in need me to pause on this screen? I know I typed 10 times. Yes.
If you could, I think you went into the source files and then just went new and then C++ class. Is that correct?
No, yes, that's correct. I went to Solution Explorers, source files, add new item, and chose C++ and called it circle.
Okay.
Excuse me, chose class, right? And then called it circle.
Okay.
And then accepted all the defaults. And once you do that, you should have a circle.cpp and a circle.h. So in circle.h, we got to declare our variables, of which there's only one, radius, and the prototypes for our methods. So the data we're going to make private. It is by default, but I like seeing that keyword there anyways. Double radius. And the methods are going to be public. We're going to add a constructor and a get area, but they're just going to be prototypes. So there's not going to be any curly braces. Well, at least there's going to be no body for it, right? If we use curly braces to set the values of the radius, so be it, but there's not going to be a body for it. So the constructor has the same name as the class. That would be a default constructor. And here it's offering to create the definition of circle in circle.cpp. This is a shortcut. And I'm going to take it. This is the prototype, but it's offering to create the function itself. I'm going to close this and actually go and look at it inside circle.cpp. If I go look at circle.cpp, this is how those functions have to be declared. With the class name followed by : followed by the function name. Now I'm not going to do get area that easy way. It's okay if you do it. I'm going to type it in by hand just for the practice. So it needs to return a double. It's called get area. It doesn't need any parameters. And now I'm going to go add it. So I'm blipping over to circle.cpp, and I'm going to add, it returns a double, and its name is circle : get area. Doesn't take any parameters, and it returns the area of it, right? Double area equals 3.14159 times, let's include CMath, # include, quote, nope, angle CMath. The quotes are just for the files that are in our local directory. So times this hyphen radius, well, let's just do POW, parentheses, this hyphen radius, comma 2. Let's pi r squared. And then let's return that value. So do you see what I mean about it being nicer if you declare, or I should say easier, if you declare your methods and their bodies in the header files? This requires you, if you're going to follow it the textbook way, to declare your prototypes here and then come over and declare your bodies here. I just think it's easier, but I guess the reason I think it's easier is because in the Java programming language, you don't split your header and your source code. So you only have one file you edit. which is what we just did in all of our other examples, right? Our animal class and our bird class and our other circle class were done like that. And here we're splitting them up. Okay, let's make a constructor now that allows us to set the area.
Quick question for you.
Yes, sir.
So in your experience in programming through your life, on average, how many source files would you have open on a single project?
Rarely are you making programs as small as what we're doing here. And so the projects in which I was involved with probably had 10 to 20 CPP files and about that many header files. And the larger the project, right, the more CPP files and the more header files.
Gotcha.
So I'm going to come back over to Circle and I'm going to define a custom constructor, not a default constructor, that takes a double as its parameter. And since we've already got the point, I am going to let the quick action do it for me. So in circle.cpp, now that default constructor is there, but I would like for it to be able to set the value of the radius based on what was passed in. So I'm going to change its prototype, well, not its prototype, its method header to accept that. And we're going to initialize the radius variable with the value of r. And there was supposed to be a colon there that I forgot. And not that curly brace there. Not s radius either. Come on. There we go, right? And so I could see out custom constructor just for grins, right? And then I could then I could see out my regular constructor, my default constructor here, and it's complaining about see out # include IO stream. I thought Circle had that in there. I guess not.
The namespace?
Did not. Yeah. Okay. So # include IO stream and using namespace std. It's not in nearly as bad of taste to put this in your CPP file because people don't # include your CPP file and unexpectedly have it declare the default namespace. But if you put it in a header file, then when they # include your header file, then it automatically declares the default namespace, and they can find that annoying. Alrighty, and so this is the default constructor. And now our project should work. I'm going to mess with this to see if I can get it all on one page at one time just by moving these up like that. Kind of non-standard, but I think it's almost as readable as the other way. All right, so this should be the entirety of my circle.cpp file. The functions are defined in it. The methods are defined in it. And you have to use a special syntax where you precede the function name with the : and the class name. And so the 2 lectures back, I tried creating a function that overrode the less than. Oh, and I think I maybe did that last time, but I'm not sure that I did it in the repeat of the lecture, so that we could print the circle to the file. Let's make sure that it runs though before we go crazy. There were build errors. Bummer. I thought I did it perfectly. No suitable class. Oh, for Pete's sake. When you do the new command, you have to declare it as a pointer. That may have created it all, done it all. At the very end, I should delete P1. But I would also like to be able to send my circle out to the IO stream, right? And to do that, I'm going to have to add that method. Now, the last time I did this, it required the data to be set to public so that that function could add it. And the way you do that is you mark it as a friend function. I mean, the way you avoid that so that that function can get a hold of private data is with the friend function. Let me see if I can find it again. A friend function is one that has access to the private data. Good old Stack Overflow. So here's the syntax for it. But we need to mark it as being a friend, so we're going to have to define it in the header file. And that's not doing it. Here we go. So I need to define my operator less than function in the header file and mark it as a friend. Friend means it's not a member of the class, but it has all the access to the data just like it was a member of the class. So I'm going to go back to circle.h. And honestly, I'm just going to copy and paste, but I'll leave it on there long enough for you to see. What's that? Oh, circle. There we go. And then I'm going to actually have to go and provide the body for this inside the circle.cpp file. So friend space std : o stream output stream ampersand. This is a reference to an output stream because that's what it's returning so that it can be sent to cout. Operator less than. And we could probably get away with leaving off the std : but I'm going to leave them in there. However, this should, since it's relying on IOStream to work, we need to actually include IOStream inside the header file because we want this to work without them having to define $2 includes. So I'm adding $include IOStream there as well. All righty, are we good, gang? Can I go and actually add this function to the CPP file? You need to look at it and type a little longer. All right, I'm going to go to circle, scroll down to the bottom. This is my prototype. I need to remove the semicolon. I need to remove the word friend. And I need to prefix it with the name of the class, I think. No, I guess not. No, it's not a part of the class, so I don't put circle : : Okay, so it takes OStream. I am a circle of radius IO. And the circle doesn't have a name yet, so we need to give it a name. C dot radius. And he doesn't like that. Oh. He needs a variable name too. So I've had to modify it, right? Because prototypes don't have variable names, or you can at least skip the variable names if you want. Not that I really usually do that on purpose, but I did this time. But he needs a variable name and he needs a variable name, and we can send out to that. I'm a circle of radius in that. So when we try to print them out, it will display that message. I'm going to go back to lecture Y2 and see if that removed our error message down here. Yes, it did. I'm going to make this a little bit sillier and put an apostrophe there and a double quote, apostrophe, double quote here. Cannot convert from circle to circle. I do have errors. Maybe it'll go away when I rebuild it. Operator must return a value. Oh, that's true. Right? Because it's declared as having a return value, so I just need to return out. All right. And so the custom constructor, it had a radius of 10. 10 times 10 is 100, right? That's the r squared times pi is that. And then we sent the circle to output and it said, I'm a circle of radius 10. And we did it textbook style by putting the prototypes in a header file and putting the functions, the actual method bodies, inside the CPP file. All righty, that's the end of the lecture. We're going to call that the end of the semester. So does anybody need to see any of these pages, or do you need me to send you the files? Because I can do that with the chat command, right? I can come up over here, pop up chat, and I can text you the files if you want them. I might even be able to copy and paste them. Last time I tried that, it didn't work. I don't want a private message. How do I send a message to everybody?
You're gonna upload this video as well?
Yes, I am. Yes, I am. All right, I'm failing on distributing this. I don't know how to get it to not just go to one person. So I'll just upload the files as I always do. Slightly disappointed. Hate it when I don't have mastery over the tools yet. Chat. Start chatting by clicking or creating a chat. I sure would love to. Forget it. All righty. So let's go make a Dropbox for it. Nobody asked to see the pages. Did anybody get it working?
I just put mine into Notepad.
Oh, okay. All righty.
It's easier for me to take notes in Notepad as opposed to C++.
I actually agree. Yes, I do. And no, we're not taking Java. So why did I click on that? There we go. I would love for y'all to take Java. Anybody in this class, if you roll in beginning Java for fall, and then this is if you need more programming classes, and then advanced Java in the spring, those give you the best concepts of all the. You'll be quite the programmer by the time you're done with those. So modules. I'm just going to tack this on to week 16 rather than create a week 17.
Are you teaching the Java class over the summer?
Not over the summer. Over the summer, I'm teaching C++ again, although I'm not sure it's going to make, and you don't need it. It's in the fall. And then advanced Java's in the spring.
Thank you.
Sure. Wish I was, but we're kind of limited in the number of classes we're allowed to teach in the summer, especially since they're twice as long. And for some reason, anyways, let's finish this up. All right, I'm going to stop the recording here. Doesn't seem like we need it anymore.